Okay, here's the last example in the notes. It's a word problem. There's a certain car, an automobile, and in the question, they tell us the velocity of the car, v of t, 2at plus 900 over t plus 10, and a is some constant. A is an unknown constant. What else do we know? We know after t equals 20 seconds, the automobile is accelerating at a rate of 0.5 feet per second squared. That's what we're given. The question says, find an equation for the position of the automobile at time t, assuming that the automobile's starting position was 0 feet. What is the position of the automobile at t equals 30 seconds? So as usual, you got to set this up. You got to figure out what is your variable. And in this particular case, there are, the variable is t time, and there are a few functions floating around that are all related. The functions, and these are the classic functions from physics. There's position, which we're going to call x of t, velocity, which we're going to call v of t. This one's actually given in the problem. So the velocity, we're told, is 2at plus 900 over t plus 10. And there's also acceleration, and that is appearing in part of the problem as well. This is a of t, and we are told the acceleration at a certain point, the acceleration at this point, t equals 20, is 0.5 feet per second squared. So the acceleration a of t satisfies a of 20 equals 0.5. What else are we told? We're told the position of the automobile started at 0 feet. That's saying x of 0 equals 0. X of 0 equals 0. And that's all we're told. I guess the other thing that you absolutely need to know to do this problem is how position, velocity, and acceleration are related, and they are related by derivatives. So because v is what we're given, we know that x prime of t equals v. The derivative of position is velocity, and the derivative of velocity is acceleration. So these will also be used. So these are the relationships. These are the given values. And we can put it all together to find the function. You'll notice in this problem, there's going to be two unknown variables. There's the unknown variable a, or they're not variables. Maybe I should use the word parameter. There's two unknown parameters. There's a, and there's going to be a plus c coming from our integration. And we have two pieces of information, so we can solve the two parameters. But let's set this up. So I'm going to start with the first half of the problem, which is this bit. A of 20 equals 0.5. And if a of 20 equals 0.5, a of t is v prime of t, is the derivative of v. And someone told me a formula for v, so I can do the derivative. It's 2a plus, and the derivative of 900 over t plus 10 is 900 over t plus 10 squared, and then you put a minus sign in front. So it's a power law. And so at t equals 20, a of 20 equals, a of 20 is 2a minus 900. 20 plus 10 is 30, 30 squared. 30 squared is also 900. So this is 2a minus 1. So a of 20 is equal to 0.5. So 0.5 equals 2a minus 1. Therefore, a equals, let's do it in steps. 2a is 1.5. So a is 3/4. A is 3/4. So the first bit of information, and knowing derivatives only, no antiderivatives, found us a. And now that you have a, you can use x of 0 equals 0 to solve for v. So x of t is a specific antideriv of v of t. V of t is this given function, 2at plus 900 over t plus 10. So doing the antiderivative, we end up with 1/2. So what's the derivative of 2at? There'd be a 1/2 t squared. So, but the 1/2 kills the 2, so we just get a t squared. 900 over t plus 10, the antiderivative is a 900 ln of t plus 10 plus c. T plus 10 plus c. So this is x of t. And we already figured out what a was. A was 3/4. So this is the formula. This is the formula for x of t, the position. We don't know the value of c yet. But if we use x of 0 equals 0, we can solve for c. So plug in x of 0 equals 0 to get. And if x of 0 equals 0, what do you get? 0 equals 3/4 times 0 squared plus 900 times ln of 0 plus 10 plus c. And therefore, c is equal to minus 900 ln 10. Minus 900 ln 10. So what's the final answer? Therefore, x of t equals 3/4 t squared plus 900 ln of t plus 10 minus 900 ln 10. That's the final answer. That's x of t. So we got it by doing an antiderivative. We used the two pieces of information to solve for 3/4 and the c value, and we just put it all together. The final part of the question says, like, what is the position at t equals 30? You can just plug in to get t of 30. Plug in t equals 30 to get x of 30. It's going to be some number. You just plug into there. Okay, that was the last for you to try.